I am very happy to be here. Thanks to Professor Zubair Lafage for this invitation. I don't have to add anything about my presentation. Thank you. The title of my presentation is about the smart technology and how it could help in transforming the construction engineering. You know, when we speak about smart technology, I don't like to use the technology for smart, because smart is more than a way of thinking, behavior, attitude than technology. The technology is something which will help to attain, but the most important thing in the smart is the way of thinking about this issue. Now, when we speak about transforming the construction engineering, one of the questions that why we have to transform the construction engineering. And the response is that, okay, we have some major challenges. These challenges are a part of the global challenges which we have. We'll first of all very quickly see what are these main challenges, and to what is the impact on construction engineering, and after to see how the smart technology or the smart thinking will help us to achieve this transformation. Now, let's look to the global challenges. One of the major challenges which we have is this question of population growth. As you can see, that we could reach 16 billion, and that the main population growth is in Asia and Africa, means in developing countries. And if we look to the developed countries, we have more than stagnation. Then what we know that in the future, we'll have more and more people in Africa and Asia and developing countries, and that this population will be mainly urban. This population will be mainly in cities. It's a very important thing. Other thing which is very important, this question of population aging. If we look to the population aging and its evolution, if we look to Europe or North America, developed countries, can see that we will reach about 35%. It means 1 over 3 will have more than 60 years old. And when we speak about this, it means that we need specific adaptation of our infrastructure, of our buildings, and so on for this population. Other thing which is really important, we have been speaking on this topic for a long time, this question of sustainability. You know, we have been speaking about this since about 40 years. And we have a lot of international world summit, and today we have also some indicators about sustainability. But the question which we have today, because we have speaking about this, you know, more in the speech than in the action. The question that me today, what's about this policy and regulation integration and sustainability? We know that in France, we did really a lot of things, but what's about the world? One of the big questions which we have today is about the share, the cost. Who pay? You know, this big question, discussion between the South and the North. It's something which is very important. And one thing which is really important, what is the real impact of what we did over the 40 years? What was this real impact? And how we can monitor this change, and what the feedback which we have. Then you see that, okay, we have been speaking on this subject for about 40 years, but it's still a subject which is very important for us, and we still have a lot of questions about this subject. Other question which is also very important, this question of greenhouse gas emission, global warming, climate change, is discussion today, and we know that it has very important impact on the ecosystem and the weather distribution and so on. And this subject also, we have been speaking about it for about now 15 years, since Kyoto, the COP21, and one of the big questions which we have today, that how we can limit the increase in the temperature to 2 degrees. This is the big question, the big challenge which we have, and it's one of the most important challenge which we have today in the world. Other thing which is really very important, if we look to the question of disaster and hazard. Here you have the number of events related to hazard. And you can see that globally we have very important increase. But the increase is mainly in the lower part, which is related to the climate. It means that we are speaking about climate change, and this climate change also leads to a lot of disaster, a lot of hazard. And we have, if we look to this example, the losses which we have in US in 2017, you can see that we reached about $400 billion. Then these disasters become more and more destructive. As you can see, the cost also becomes also very, very important. But when we speak about hazard, it's not only about natural. We know that today we have other things. We have the fire, we have the industrial, we have the outage leak, building facility failure, we have the cyber attack today, which is also very important hazard, and we have also social and economic. Then, when you speak about hazard, the picture is much larger than only natural disaster. And if we refer to Judith Rodent, who is the president of the Association for Resilient Cities, she said that the crisis is becoming the new normal. The crisis is becoming the new normal. Before, the crisis was exceptional event. And we know that in civil engineering and construction, our design was related to some exceptional event, 50 years, 100 years. But today, the frequency is much higher, and today, that this hazard comes really daily, and we have to revisit our regulation concerning the design of civil engineering or construction, concerning this question of hazard. And today we have to learn. We have to learn from our disaster, from our accident, then this question of resiliency, how we can learn and prepare. Today is not an option. It's a must. We have today to involve this question of resiliency also in our design. Other thing which is also, when you speak about life cycle management from the planning to the operating phase, which is really very important. If we look to the operation or the operating phase, we can look for some example in buildings. About 70% of the global cost concerns the operating phase. And when we speak about the construction industry, today it focuses mainly on the construction. It's about 30%. Then the question today is how we can also, as responsible, integrate this life cycle. And here we have different questions. First question is that how we can make the evaluation, not only the evaluation, and the share. How we can share this global cost. Should we invest more to reduce the operating cost or not? This is a big question, and we have to discuss about it. Other thing which is really very important, when you make the design and the construction, it's not related to the operating phase because we don't have the same actor. We have the architect, we have the companies, but they don't operate these buildings. And today we see that for the operating phase, we need some requirements. We have some specific things, and we have to integrate the requirement of the operating during the design and the construction. Then it means that we need, from the beginning, to have this discussion between the operator and also the architect and the construction company. Other thing which is really very important, since we don't have the same actor between the plan and design and so on, generally we lose a lot of information, a lot of data. And the question today, if you look to this picture, you can see that at each phase we lose this data, and these data are very important for us. The question that how we can today conserve all of these data, and that this data go smoothly between the stakeholders. Now the question is, okay, what is the impact on construction engineering? We have construction companies, and what is the impact of all of this? First of all, the question of the city. See that today the city becomes a focal point. Focal point because of the human concern. We know that more and more people today live in cities. The GDP is very high. And the environmental concern, 70% of the energy consumption and 80% of the greenhouse gas emission. When we speak about global warming and we want to act on the global warming, it's evident that we have to act in the city. It's 80% of the greenhouse gas emission. Then the companies today, they cannot avoid this point of the city, and we have to integrate this question of the city. Now, when we want to integrate the question of the city, as construction engineering companies, mainly we focus on the built environment, buildings and infrastructure. But when we look to the city, it's much more complicated. We have the community, we have the governance, the management, we have the natural environment, we have the economic social activity, and we have the question of hazard. And the companies today cannot only focus on the built environment because all of these issues are in interaction. These issues are in interaction, and companies today have to think about the community, about the governance, about the natural environment, the activity, and so on. Then we have the city, and we have to integrate the city with its different issues. Now, when we look to the less developed countries, we said that the main increase in the population will be here. You know, in Africa, we have 1 billion, and it will go up to 4 billion. When we speak about 4 billion, it means that we need a lot of infrastructure, a lot of construction, and so on. This question of this is a huge need for the built environment, and also all the associated services. The question also that how we can integrate today the question of sustainability, life cycle management, resiliency, performance, quality control, and so on. Because it's not only to make the construction, we also to make this construction which are also responsible concerning the environment and the society. The big question today is about funding. We know that we don't have enough money today. Then which economic model can we use? It's a big question. About the governance is something which is very important. The question of transparency also something which is important. And one of the most important things is the question of building capacity. There is a huge need for construction, for design, and we need people. We need people for the design, for the construction to run. Then we have a huge need in building capacity. That's the role of the universities, the education institution, international cooperation, companies also. This question is really crucial when we speak about developing countries. When we look to developed countries, one of the big questions which we have is infrastructure aging. You know, this infrastructure were mainly after the Second War, about 60, 70 years. And if we look to this report of the ACE about the evaluation of the infrastructure in the United States, in a scale between A and E, it's D+. It means that we are in one of the most advanced countries, but with very, very bad infrastructure. You have the same thing. If you look also the UK, we have the same thing. A lot of countries, developed countries today, they suffer from this problem of aging infrastructure. They were constructed at a time where we didn't have the requirement for sustainability and so on, and today we have them. Then we have this huge need for renovation to meet today's requirement concerning sustainability, circular economy, resiliency, and also the population aging. We have also, this is a report from EY, recent report, that one of the big questions which we have in developed countries is the declining workforce. You know, it was mainly manual, and today we have some, a very important evolution in the working force. The question of productivity, if we compare the construction sector with other sectors, automobile and so on, we have some stagnation in the productivity. The margins are not so high. The failure, we have some projects, very important projects today. We have a budget, and by the end, we can double the budget with a very important increase in the budget, and we have this failure in the budget. And as we said before, this question of transparency is also very important. Then there are also some of these challenges. Now, when we have fixed these challenges, the question of the smart technology, generally we speak more about the smart city. Do you know that all big cities today, they have their own project concerning smart city, and you have here some of these examples. And you have also very important projects almost everywhere in Europe, in China, in India, in Africa, and so on. Then today, the question of the smart city becomes very popular. A lot of cities today are interested, or they have some projects sometime. We don't know what is it exactly, but we are interested to do something in the smart city. If you look to this report from the Association of Electrical and Medical Imaging Equipment in the United States, we are speaking about the smart grid that concerns electricity. The smart grid will change the course of the human history. This conclusion is really very important. It means that this technology is not a small technology. It's not a small transformation. It's something which is huge, which is very important, and we expect a lot of things from this technology. Now, this technology, which is very important, is that it's inspired from the human intelligence. When we speak about the human intelligence, we have these three components about sensing, cognitive, and action. And also, we will learn from the experience. This is how the human brain works. Now, if we want to use the same scheme, for our infrastructure, for our cities, we have also our city concerning the community, the built environment, and the management. One of the first steps is how to transform this city using digital model and to put it in an information system. How I can describe my city, my district, my structure, and so on, and put it in my computer and my information system. Second thing, which is very important, is the sensing layer. How I can feel things in the city. Then I will add some sensors, other things, and so on. Then the sensing layer is very important. And we can collect all of this data. We have this capacity of analysis using engineering, management, IT, and we can make action. And in order to put this action in our city, we have the control layers through actuator and so on. That's how our system works. Then you can see that we have the sensing, we have the thinking, and we have the action. And the same thing, we will record all of this information, and we will also learn from our experience. That's how this system works, and we will learn from events, from data, and so on. And you can see that the most important thing that we will start from data, transform our data in information, the information in knowledge, and we will use the knowledge for the management. This is which is very important when we speak about the smart technology, how we can go from the data, something which we use in our management, and we'll use management which is based in knowledge. Now, the digital technology which will help, we know that the internet, the mobile, the disconnection of the population at very high scale is very important. We live today in a connected world. Other thing which is important, the Internet of Things, this small equipment we can put almost on everywhere. We have today more than 20 billion. And they have the capacity of sensing, but they have the capacity of analysis, the communication, control, automation, and so on. Then, also, if we look to the objects or the things, they are also connected. And what is very important in our world, people are connected, things are connected, people and things are connected at large scale. Second thing which is important, if we look to this connection, with our mobile. In some mobile, we have about 19 sensors. We have sensors for light, proximity, and so on. Then the mobile is not only to give some phone call. Today, we can use the mobile really to monitor. We will give you some example about this. And if you go today on some construction site, the mobile is used almost everywhere as interface. Then the mobile today becomes something which is very important. Today we have more than 5, 6 billion of mobile. This huge capacity for the mobile is really very important. Look to this in new papers, 2017. It's about how we can use the mobile as sensor, or urban sensor. It could be for the bridge health monitoring, it could be related to acoustic and so on. More and more papers today, research today, are focused on how I can use the mobile. Why? Because the mobile is everywhere. We don't have additional cost. And if we succeed to convict people to work with us, we have source which is really free. It's very important. I will give you another example. The tags. Tags is really very important, for the question of identification. And here we have the process, how we can put the tags during the fabrication, the logistic, and so on, up to the beam. It means that today we have this capacity to identify any object, and to follow this object to see what's going on. Robotics and 3D printing, it's the topic of this conference. We can go very quickly about this. We have also the drone, robotics, 3D scanning, also something which is very important. And we speak in civil engineering, GIS, BIM, augmented reality. Then, as you can see, that we have already a lot of tools and possibilities to connect to things and to connect to people. The second question that now we have a lot of data, what we can do with this data. We know that we have a lot of mathematical tools, the big data tool, the artificial intelligence, which are very powerful tools for the data analysis, and they are general tools. They are very easy today to implement and to use. And here you have also some example about the use of the artificial intelligence in urban studies. You have something which is really recent. You can see 2017, 15. And the same thing for the big data. It's also used today in the construction, civil engineering, urban engineering. Then today it's not only, it's something which is really used, and it's something which is really very powerful. EY made a report about where we can play in the construction, and we have something which is concerning the impact and the likelihood. And you can see that we speak about integrated BIM, we speak about real-time mobile collaboration, wireless monitoring, and so on. All of these digital technology are put on the top where companies should play in the future, because they will increase their efficiency and so on. Now, when we speak about the construction engineering, what are the main changes? One of the big things is this question of the comprehensive. Before we have the building, we thought about the buildings, was our main object. Today, when we speak about the building, as we said before, it's related also to other phases. Then, it's not only the construction phase, it's all these phases which are very important. Other things which are really important, the question of the user, the community involvement, the eco and social-friendly, circular economy, resilient, efficient, innovative, the question of how we can monitor this system for performance evaluation, the question of data and for sharing, and so on. Then you can see today that when we have a construction project, it's not only the construction which is needed. It's all of this picture we have to think about to see how we can interact with all of these issues. And if we look to the process, something which is very important, we have to start with the question of data and the question of analysis, how we can make decisions, and after what we can do through this construction operating. If we take a new project, we start by collecting all of this data, physical data, environmental data, data from stakeholders. We have this information. And what is really very important, that all of this information and projects, we put them somewhere in the warehouse. It means that we will learn from other projects. And it's something which is really very important. From this, we can use the expert, some analytics, and artificial intelligence to make the analysis. And in this, what we can do, we have some scenarios, some option. We can analyze this option, and we can present this option for decision-making. They have different solutions, and they have to choose according to some criteria, and they can use the solution after we go in the construction operating phase. And what is the important? All this feedback from the design construction team, users, other stakeholders, performance, and to come back to the warehouse. This is the process, how it works. As you can see, the most important thing that is this global picture, that everyone has his position and his contribution, and this return that we want to learn. We want to learn, we learn from the experience, we learn from the feedback, and we should store all of these data in this project house. I would like to give you one example. Unfortunately, this example is not related to construction. We have a new example, construction was a new project. We don't have yet enough data. I will give you something about the smart city demonstrator to see how did we really use this technology. We have started with a large-scale demonstrator of the smart city with companies, local governance, the international level, with the European Commission. We said that we need a large-scale demonstrator about this technology. And we said that why we cannot use this campus. This campus is a small city. You see that we have about 25,000 users, 140 buildings. Some buildings are old buildings. We have new buildings. Some students live in the campus. Then this city looks like a small town. And what was very important that we have all the urban utilities. Drinking water, sewage, as you can see, 100 kilometers of utilities. You can see this, the GIS of these utilities. And what we did, this is the support. You can see that we have all the support from the European Commission, the local governance. What was very important for us is that we have a lot of students who came from all over the world. We have about 30 students who came to work on this project. Some are in civil engineering, in mechanical engineering, in IT, and in social sciences, and we work together to see how we can build, how we can do something about this technology. I will give you this example, which concerns the water. If we look to the water system in the campus here, we have the picture, and just beside you have the picture of some of these pipes. You can see these pipes are very old, and we have a lot of problem with these pipes. We have a problem of leak, problem of quality, and so on. Then we have two big questions when we started this project, how we can reduce the leak and how we can detect any contamination in the water network. Then what we did, we monitored all of this network. We put our sensors, which you see here, to measure the water flow. In the red color, it's the input, the alimentation of the campus. In the blue, it's the consumption then. And we have the data every hour. It means that every hour we can make the balance between the supply and the consumption. And we can see that if we have some leak. Every hour we can do this. I give you this example, this result. Here we have the leak. You see, the first part, we have about 500 cubic meter of leak every day before we have used our system. After, you can see that we have some results which are really very interesting. Take this example. You can see that we have the leak, we detect the leak, we repair the leak in only 1 day. And you have these events after. In only 1 year, we made an economy of about 130,000 euro. And the global investment which we did on sensors was about 30,000. Something which is very important about this. Here were all the leaks which we have resulted. The second thing, which concerns the water contamination, we have also used some advanced devices to measure all of these parameters, pH, UV, and conductivity, chlorine, and so on. And we can get the data almost every 2 minutes. And you can see here also some of these results. You know, when it's horizontal, it means that it's normal, and sometimes we have this change in the water quality. It means that we have something. And this something, it was mainly in the morning when students come in the building and the water flow, because the problem we have some stagnation and so on. It means that if we cannot change our pipes, we can start by what we call that, okay, we can, before the students can come, we can make some flash for our network and so on. This result also was very important, and we made also some risk analysis concerning the likelihood and severity, and you can see here, using this analysis also, we can decide what is the level of risk concerning the water quality. To resume, if we speak about this construction engineering, it's a question of challenges, but also a question of responsibility. It's something which is very important. We spoke about the increased demand, the question of update of the built environment, sustainability, global warming, and so on. Then we can see that we have a lot of challenges in our sector. And these challenges, it's mainly for companies, but also for the academia also are concerned by these challenges. And today, the society and the public authority ask the engineering construction sector for higher social responsibility, and also to make more innovation to meet these challenges, because the question of integration of sustainability, circular economy, the technical innovation, the training and building, capacity building, and we know that what is really interesting by this smart thinking, that we can do something which is comprehensive, cost-effective, user involvement, transparent, well adapted for socio and technical system. Thank you very much.